Okay, so section 4.5 is about quadratic equations, and we're going to solve them by factoring. So hopefully you didn't forget all of the factoring we did at the beginning of this unit. So solutions of a quadratic equations have a few names. The most common are either roots, so roots, or zeros. So if you hear somebody ask you to find the zero of a function or the roots of a quadratic equation, this is where the function crosses the x-axis. So in this one right here, the roots would be at 1 and 3. So the solutions to this problem would be x equals 1 and x equals 3 because there's 2. So let's also talk before we get into solving. Sometimes you'll have no solutions. So when would you have a no solution graph? Well, that's whenever it's like you have a parabola that is above the x-axis. It's not ever going to cross the x-axis. Okay, so this would be no solutions. This would be 2 solutions. And is there ever a time that there's 3 solutions? Or sorry, not 3, 1 solution. Yes, there is. It's whenever the vertex is on the x-axis. So whenever this would be 1 solution. Okay, so there's a few different ways to solve these. The first way I'm going to teach you is to solve by factoring. So solve each equation by factoring, check your answers. So what you need to do first is you need to factor. And then step 2 is set each, I'm going to say, piece equal to 0. And then solve those pieces. Okay, so on this one, let's factor it. Remember, we're looking for what adds to be 5 and multiplies to be 6. They're both going to be positive, so that would be, what, 2 and 3? So since there is no a value besides 1, we can just straight up do it. We don't have to factor by grouping. So this would be x plus 2 and then x plus 3. All right, now let's set each piece equal to 0. So we'll have x plus 2 equals 0 and x plus 3 equals 0. And solve it. So you would minus 2, so x would equal negative 2. And then you would minus 3 to both sides, so x would equal negative 3. Okay, so your solutions, this one has 2, would be x equals negative 2 and x equals negative 3. Is there a way to check this? Yes, there is. So let's check it, and if we do it right, the equation should equal 0, just like it says. So let's check. So negative 2 squared plus 5 times negative 2 plus 6 should equal 0. So that would be positive 4 minus 10 plus 6 would equal 0. 4 and negative 10 is negative 6. Negative 6 and positive 6 is 0, so this would be 0 equals 0. Check. That one works. Okay, negative 3 squared plus 5 times negative 3 plus 6 equals 0. So that would be 9 minus 15 plus 6. 9 and negative 15 would be negative 6, plus 6 would give me 0 as well. So check, that one works. So if you were unsure of a problem or you were on a quiz or a test, definitely you should check your work to make sure it does equal 0 or whatever's on the other side of the equation, like in the next instance. I'm not going to do this every time, but you definitely could if you would like to. Okay, the next one. So are we ready to factor? No, we have a problem. There's not a 0 on one side, so we can't factor. We have to move everything over. So let's do that. We're just going to add 56 to both sides. So that would give me a squared plus 15a plus 56 equals 0. All right, I'm ready to factor. What adds to be 15 multiplies to be 56. It's going to be 2 positives. And our a value is 1, so we do not have to factor by grouping. We can just give the answer. Have you thought of it yet? It is 7 and 8. So this will be like a plus 7 times a plus 8. Okay, now set each piece equal to 0. A plus 7 equals 0. A plus 8 equals 0. Therefore, a equals negative 7 and negative 8. So this one has 2 solutions as well. And you could check it if you wanted, but we're not going to. Okay, this next one is a little different. We still need to get a 0 on one side. Every single time you have to have a 0 on one side in order to solve it. So let's subtract 2b to both sides. And remember, you cannot combine those because they don't have the same exponent. So this would give you b squared minus 2b equals 0. All right, we are ready to factor out. What can we factor out? It's not a normal factoring. You have to factor with the GCF. So it looks like you could factor out a b, and that gives you b minus 2 equals 0. Okay, so this is a little bit different. So you'll have this piece, just the b, and then also this piece. So you still have 2 pieces there, just look a little different. So you're going to have b equals 0 and b minus 2 equals 0. Sweet, so this one's already done, b equals 0, and then this one you would add 2 to both sides, so you get b equals 2. All right, the next problem. Again, I couldn't just give you one with a 0 on one side. We have to move stuff over. I like to move it over to the left so my a value is positive. You can do it the other way. This is the way I prefer. And I'm going to do them both at the same time. So this would be 3x squared minus 16x minus 12 equals 0. And this is the one that, since a does not equal 1, we do have to factor by grouping. And we do have to say what adds to be the b term, so it adds to be b, and multiplies to be a times c. So it adds to be negative 16 and multiplies to be negative 36. So what is that? Looks like it's going to be a positive and a negative, and your bigger number is negative. That's going to be negative 18 and 2. So let's go ahead and factor by grouping. We have 3x squared minus 18x plus 2x minus 12 equals 0. Put your parentheses in. The first set of terms you can factor out looks like a 3x. That would give you x minus 6. The next set you can factor out just a 2, positive 2. So that would give you x minus 6. Good, our parentheses match, so we're almost done. We've got 3x plus 2 times x minus 6. Okay, all that equals 0. Now set each piece equal to 0, so we'll have 3x plus 2 equals 0 and x minus 6 equals 0. I'll do the easier one first. Add 6 to both sides, so x equals 6 there. On the other one, you're going to subtract 2 to both sides, so 3x equals negative 2. Divide by 3. Uh-oh, we have a fraction. It's okay. So x equals negative 2/3. Perfect. Let's go to letter E. Good, everything is on one side of the equation, so we don't have to do that. So let's just factor out with the GCF. Looks like you can factor out a 2x. So that would give you 3x plus 2 equals 0. So then again, this is a piece and this is a piece. So the first piece, 2x equals 0, and the second piece is 3x plus 2 equals 0. Divide both sides by 2, so x equals 0. There's 1, sweet. Subtract 2 from both sides, so 3x equals negative 2. Divide by 3, so x would be negative 2/3. Another fraction. Okay, last one. Letter F. Of course, I can make it easy on you. I'm going to move this one over and add 10 to both sides because I want it to be in standard form, because remember the x squared needs to come first whenever you're factoring these. So I will have negative 3x squared plus 7x plus 10 equals 0. So I'm looking for what adds to be 7 and multiplies to be negative 30. That would be a positive and a negative, and my bigger number is positive. So it would be 10 and negative 3. So I would have negative 3x squared minus 3x plus 10x plus 10 equals 0. Let's do some factoring by grouping. So you could factor out, looks like a negative 3x from both terms there. That would give you x plus 1. Factor out a positive 10 from here, and that would give you x plus 1. Sweet, they match. So negative 3x plus 10 times x plus 1. Last step, set each piece equal to 0. So negative 3x plus 10 equals 0 and x plus 1 equals 0. I'm going to solve the easy one first. X equals negative 1. This other one, I'm going to add 3x to both sides so I don't have to deal with the negative. It doesn't matter if you want to subtract the 10, you'll get the same answer. So 10 equals 3x. Divide both sides by 3. So your x equals 10/3. Can I simplify? No, you can't. So you could write it as x equals 10/3, kind of prefer that way, or if you really want to convert it, as long as you don't make a mistake, that would be 3 1/3. All right, that is all I have for solving equations by factoring.